Hi guys, welcome to the last day of exponential functions, and today we will be talking about compound interest. Sorry for the lack of videos last week. I had a sinus infection I was getting over and I kept losing my voice, so I figured I would just have you guys do some review work. So this is our last piece, and then we're also going to test this week because this is just a small piece. Alright, so this will continue with your EQ11 notes. So you probably want to pause the screen after I stop talking in just a moment to copy this formula down into your notebook. Now, let me say this. Anytime you're taking a quiz or test, including T and Ready, you are going to have access to these formulas. So the formulas that you would have access to on testing would be this one for compound interest. I'm going to go backwards to this screen. You would also be provided with the growth formula and the decay formula, a times 1 plus r to the x and a times 1 minus r to the x. You are responsible for knowing the exponential equation y equals a times b to the x, and you are responsible for knowing 1 minus b times 100 to find the growth or decay rate. Okay, so again, let me just go ahead and have you pause now and copy this into your notebook, and then I'll go over it. All right, so this is the compound interest formula. This is a formula that's used in the real world. This is used for anything with banking, loans, car loans, student loans, home loans, stock markets, 401ks, retirement plans. Now, most of the time we are not doing it by hand anymore. It's usually, a computer program that's doing it for you. But it is something you could use to help you if you're trying to calculate how much interest you're going to pay on a loan, for example. So A is your amount, meaning your total amount, so whatever you're going to end up with. P is your principal, which means initial value, okay? So if it helps you to make a note that principal is the same as your initial value, you can. It's always going to be 1 plus, like the growth formula. R is our interest rate as a decimal. So remember, if our interest rate was 25%, we would change that by moving the decimal 1, 2 to get 0.25. T is our time in years. And N is the number of times the interest is compounded per year. Okay, compounded per year. And notice that shows up twice. We'll be putting that in twice. The next thing I want you to write down in your notebooks are these words. Okay, because you'll need to know if it says yearly or annually, that means N is 1. Semi-annually, N is 2. And so on. Let's go ahead and take a moment to copy this into your notes as well. All right, so here we go. So when we are doing compound interest, again, you do not need to memorize the formula. You just need to know how to plug into it to use it to solve a problem. Okay, so again, we have yearly or annually. Our N is equal to 1. Semi-annually is 2. Semi means twice. Quarterly, 4. Monthly, there's 12 months in a year. And then daily, 365. And if something else pops up, we'll talk about it as we get to it. So we're going to look at our first example here on this interactive notebook screen. So we have you deposit $1,000 into a bank account that pays 10% interest compounded annually. How much will the account be worth after 5 years? So we're going to work this one out together. All right, so I'm going to change colors here so it will show up. All right, so we have, actually before I change colors, we're going to do this. So my ending amount, remember that's basically my total, right? P is my principal, so that's going to be $1,000. That's what I started with, okay? My rate is 10%, which would be 0.10. Compounded annually, so once. Okay, and my total number of years is equal to 5. So now I'm going to change colors, and then we're just going to plug in. So we're going to have A equals 1,000 times 1 plus, again my R is 0.10, over my N is 1, and then to the nt power, so 1 times 5 power. Okay, so then when you put it in your Desmos calculator, you always want to make sure that this part up here, your exponent, you multiply first. So 1 times 5 in this case would just be 5. And then we're just going to put it straight into the Desmos calculator this way. So give me just a moment to pull up our Desmos calculator so I can just show you. Alright, so here we go. So I've got 1,000 parentheses 1 plus 0.10 over, oops, made a little mistake there, 0.10 over 1. If you make a mistake, just fix it. And then it was to the 5th power. Oops. So we get $16.10.51. So $1,610.51. So that one rounded out pretty evenly for us. So then after 5 years, that account would be worth $1,610.51. This one came out evenly. Most of the time you're going to be working with, or really all the time, you're going to be working with money on compound interest, so you're always going to want to round it to 2 decimal places. Alright, so what you're seeing on the screen now is a real-world example of how you can use the compound interest formula. So this is not my up-to-date information because this is the screenshot I put in last year. But this is my IRA. So basically this IRA is kind of like a retirement account. When I used to work for Verizon Wireless, I had a 401k, which is a retirement account. And when I left there, you can't just cash it out and keep it without getting hit with a lot of penalties. But you can roll it into an IRA where it will just sit and continue to make money. So in February 2020, this was the value of my account, $43,830.59. This is the amount I started it with initially when I put it into that IRA. So you can see that it's grown quite a bit since it's been in there. This is my rate. And this is an annual account. So just for example, what you could see is how much my account would be worth if I retired after so long. So let's just say that I'm going to retire in 25 years. Okay, so that means we would put in my $43,830.59 times 1 plus my rate, 0.0901 over its compounded yearly, times 1 times 25 years. Okay, so then we would put this into our calculator. So 48,830 0.59 times 1 plus 0.0901. Over 1, because it's yearly. And then we would do 25 years. Okay, so if my account continued to grow at that same rate for another 25 years, it could be about $422,000.36 when I retire. I know that now it is more than that. It's not, oh, I put it in wrong. It's 43,830, sorry. So that's 378,822.5366. So, you know, that's as it is right now. Now, of course, that's if there's no fluctuation, because what we're doing right now, even though this is a real world application, that rate can go up and down. Just like I'm sure you guys hear in the news that the stock market can crash and rise. So when the pandemic actually happened, my account actually lost $10,000. So it dropped $10,000 down to $30,000. However, it has rebounded since then. And in the time that it's rebounded, it's now worth $51,620.43. So let's look at it from that perspective. So 51,620.43. And my rate in the last year has changed because it changes depending on the fluctuation of the market. Okay, so based off of that new rate, based off of the new rate that it's been going at, and I'm going to change this to 26 years because that would put me, at being 65, I believe. So we got 5120. Yep. So then at that point I would have $584,000.17, which is pretty good, right? Like, it's a pretty good amount of money to have set back when I retire. And then my husband has one of these accounts as well. And then we have our Rutherford County Schools account. So, if you start saving money early and just let it sit in an account like this, like, we don't touch it, we don't add anything to it, we don't take anything away from it, it just grows. Okay, so there's your real life math lesson for the day, because I know you guys always want to know how, could this affect me in life? Well, this is how I can actually estimate and see how my money is growing and where I'm estimated to be. So let's look at some examples here. I'm just going to have you guys try a few of these. So your 3-year investment of $20,000 received 5.2% interest compounded semi-annually. What is your total return? So let's change colors. How about light blue? So my principal is $20,000. My rate, I'm going to take my 5.2 and I'm going to move it 1, 2 to the left. So I get 0.052. My time, so 3 years. And then my compounded semi-annually. And then to get the amount we would solve. So I'm going to put in, or you're going to put in 20,000 times 1 plus 0.052 over n2 to the nt power, so 2 times 3. So remember, when you put that in the calculator, you'll actually put it in like this. 2 times 3 is 6. And go ahead and solve it. So I'm going to solve it on my calculator. While you're putting it in your calculator. Okay, so I'm not going to do the on-screen calculator this time. I'm doing the Desmos calculator on my phone. So 20,000 times 1 plus 0.052 over 2 exponent. Make sure you hit that exponent button, a to the b to the 6th power. Alright, and when I put that in, I got, and hopefully you got the same, 23,329 and 97 cents when we rounded. 968, so 0.97. Here's another one. You borrow $59,000. That's our principal for 2 years. It's our time at a rate of 11%, 0.11, compounded annually. What total will you pay back? So this is one where we're not looking at making money, but we're looking at if I take out a loan of $59,000, how much to actually pay back. Because hopefully something that you guys know, even though you haven't taken loans out yet, is you never pay back the amount you took. You have to pay interest. That's how they make money on loans. So we'll put this one in, 59,000 times 1 plus 0.11 over 1. And then 2 times 1 is 2. So again, let's go ahead and put it in our calculators. 59,000, parentheses, 1 plus 0.11. Since it's over 1, you don't have to put the over 1, since 0.11 over 1 would just be 0.11. Or if you just want to do it just so you're in the habit, that's fine. Close parentheses. Exponent button, a to the b is 2. And we end up with $72,693.90. So even though you only borrowed $59,000, you end up paying back $72,693. So that's a difference of $13,693.90. 11% is not a good interest rate. You'll learn that when you get older. But when you're looking at interest rates, you want as low as you can get. Because the higher the rate, the more money you pay back. All right, we're going to do just a few more. And then I'm going to have you do some delta math. So maybe just one more. So your allowance of $190 got 11% compounded monthly for 1.67 years. What's its worth after the 1.67 years? So my allowance was $190. It was compounded at a rate of 11% monthly. There's 12 months in a year. Oops, wrong place here. 12 months in a year and 1.67 years. So what is it worth after the 1.67 years? So again, we're going to plug in 190 times 1 plus 0.11 over 12. How many times it's compounded? To the 12 times 1.67 power. Remember to multiply those two numbers. If I can get there. 12 times 1.67. So that's going to be 20.04 is what you'll use for your exponent. So 190 times 1 plus 0.11 divided by 12 months in a year to the 20.04 power, $228.12. Okay, so again, compound interest. You will be given the formula. It's all about understanding what each piece means. Okay, you'll be given the formula, but it won't say rate of interest, time in years, number of times per year. It'll just say A equals P times 1 plus R over N to the NT power. So you do need to know what each piece means, and you need to know how to plug in. Okay, how to plug in. When you take your test later this week, it's going to be on Mastery Connect, so you won't be able to see your formulas there. But I will try to have them listed in Kidem. Or you can just look in your notes since you guys are at home and you'll have your notes there with you. All right. So you're going to get on Delta Math. We are finished with the assignment, so let me see if I can pop over to Delta Math. All right. So on Delta Math, you should have already completed Table to Exponential Function, Exponential Function Basic, and Finding Growth and Decay. Those have already all been assigned and should be completed. All of these together make 1 grade. Okay, all these together make 1 grade. So notice how this is my fake student account that I just used to preview what your lessons will look like. So notice right now I have a 20% because I've only completed 1 of 5, 1 of 5, 2 of 5, 0 of 5. Okay, so after today, if you completed it, it'll be a 100, and when I enter your Desmos grade, it should be a 100. If not, you need to have all of these completed by the end of the week. We will not be restarting right now. So compounding, solve for future value. So you are going to need that formula for these, okay? Because you're going to have principal amount, your rate, compounded continuously. Oh, that's interesting. Aaron invested $570 in an account paying an interest rate of 7% compounded continuously. Assuming no deposits or withdrawals are made, how much money to the nearest dollar would be in the account after 8 years? Let's look at show example. I want to know what they mean by continuously. Did I misread it? Let's just click see solution. Yes, yes. Oh, we may not be able to do this assignment, guys, because it looks like this one has other compounding in it. All right, so change of plans. I'm going to remove this one from your lesson, so you'll just have to complete the other 3. And what we'll do instead is there is an exit ticket at the end here with 3 questions on it. I know you can't see it right now because of this whole snooze thing. But what we will do is I will post that in Kidem, and that's what you'll do instead since we cannot do Delta Math. Okay? Make sure you do your LHS Mastery, and then on your next day of class this week, whether you're an even person, it's Wednesday, or an odd person, it's Thursday, you'll be looking over a review that I'm going to do with you via video, and then you will be taking your test, and you'll be done for the week, and have a great spring break if all of your assignments are turned in.